Alright guys, this is section 7.4, evaluating logarithms and graph logarithmic functions. Now, we're going to do just the first part today, so we are going to evaluate logarithms on this video. The next video we will graph them. Now, a logarithm is rewriting an exponential as a logarithm. Now, a logarithm and an exponential work kind of like a square root and a squared work. So if I have x squared, if I'm going to undo my squared, I'm going to square root. Now, if I have an exponential function, so if I have something like, or an exponential equation, so if I have something like 2 to the x, and I want to solve for x, I'm going to have to use a logarithm to get rid of my 2 and bring my x down. Now, here are the two equations. So we have a equals b to the p, which goes to log base p, a equals p. So I have my answer is equal to the base to the power, and then I have the logarithm of the base of the answer is equal to the power. I know this looks confusing, but it will be less confusing here in a minute. The only thing I want you to really know is that these two forms, so this one and this one, are equivalent. Now, let's jump into an example. And what I meant was I have the logarithm right here. So I have log base 3 of 81 is equal to 4. So it's going to match this. So I'm going to have my a, which in this case is my number here. So I have 81 is equal to my b, and I'm trying to make it look like this. My b is equal to the base of my logarithm. So I have 3, and then my power is what comes after the equal sign. So I have the power of 4. So 3 to the 4th power is 81. Now, there is a fancy little gimmick that we can use to help us remember it. We're going to start at the base, and then we're going to draw a heart. So I'm going to go here, and then I'm going to draw a heart to my 1, and then to my 7. So it's going to be 7 is equal to, I'm sorry, 7 to the 1st power, because we have our 1 here, is equal to 7. So if I draw this little heart, then this is my first number, my power, and my answer. Just like here, I have my base, my power, and my answer. So let's do the next one. So I have my heart, which I'm going to draw. So I have 14 to the 0 power is equal to 1. So I have my base 14, which is to my power 0, which is equal to 1. And this works every time you have a logarithm that's in this form. And the last one, we should draw our heart. So I have 1/2 to the negative 5 power is equal to 32. Now, looking back at these equations again, I have my answer is equal to my base to a power. So answer A, base B, P, power. Now, when I change it to my logarithm, I have log and BAP. I know the word BAP is not a word, but we have log of B, A equals P. That may help you remember how to switch back and forth. You can also use the heart thing if that works for you, but you have to make sure on both of these that the equal sign is on the right side of the log. Now, next thing is evaluating logarithms. We are going to rewrite in exponential form. Now, exponential form is the a equals b to the p. So we have our exponential form, which is a equals our base to our power. So we have our logarithm here. Now, we can set this equal to x or a so that we can solve for our answer. Now, if I do it like this, then I'm going to have 2, and I can draw my little heart like this. So I have 2 to the a is equal to 32. Now I have to figure out what my power would be to make my answer 32. So I'm just going to do one thing. I'm going to say 2 times 2 is 4. times 2 is 8, times 2 is 16, times 2 is 32. And I had 5 2's, so my A is equal to 5. Now, another way we could do it is we could set this equal to P, just like in our log equals BAP, or log of BAP. So I have this equal to P. So I have 27, and I draw my little heart. So I have 27 to the P power is equal to my answer. So if I have P here, 27 to the what power is going to give me 3. Now I know the cube root of 27 is equal to 3, so what I can do is I can just make this a fraction so that I end up with a cube root. So I'm going to say P is equal to 1/3. Now if we look at this, if I say 27 to the 1/3 power, you guys would rewrite it as cube root of 27, which is equal to 3. So P is equal to 1/3. And the last one, 0.2 is the same as 1/5. So I'm going to set this equal to P. So then I have my heart, like this. So I have 5 to the power is equal to 0.2, or I can write it as 5 to the power is equal to 1/5. Now, what do I need to know about my exponent to make this number move to my denominator? Hopefully you said I need a negative exponent. Now, if I have a negative exponent, then I need to figure out if it has -1 or -2. And by doing that, I can look at what my power is down here, and it's to the power 1. So I'm going to say my power is equal to -1, because 5 to the negative first power is 1/5. Now, the next thing is the common log or the natural log. Now these are the basic ones that you can use with your calculator. So if you see log of x, so if you just see this, then you can assume that our base is 10. Just like when we see x, we assume that it's to the first power. Same concept. And here, if we see log of e, then we can assume it's our natural log. So if you see a natural log of x, you can assume it's log of e. And we learned about e's last section. Now, when we're solving ones that look like this, calculators are a great resource for these because we can use our calculators. We cannot type a base of 2 into our calculator, but we can type in log of x, which has a base of 10. So, if I go to my calculator, and if you have a calculator that looks like the yellow calculators in the classroom, then you can find it right under the second button. Or last time when we were using the exponential function, we typed in second and then the ln button. So there's our natural log button, which is right here. Our log button is going to be right above it. So we have the log button like this, and then our natural log button is right underneath. So what I'm going to do is I'm just going to type in log of 12 into my calculator, and it gives me approximately 1.08. And I'm going to do that for all of these. So I have log of 102, and you can type that into your calculator first and make sure you get the right answer. And it is approximately 2.01. The natural log of 0.03 is equal to -1.2 approximately. Now, this is an approximate sign because the equal sign means it's only this. But since there's more decimals here, I'm just going to write an approximate sign because I rounded somewhere. Now, in the last one, you can do it yourself again before I tell you the answer. And it is approximately 3.09. Okay. Now, moving on to the next page. We are back to inverses. So the inverse of log base p of a is equal to p. Our inverse of that is going to be our a is equal to base to a power. Just like what I said back here. These are inverses of each other. They are equivalent forms, so they have the same purpose. Now, inverses are opposites. So they undo each other. So I can use this to figure out how to undo all of these problems. Now, pay attention to the first one very, very closely. So I don't have a base here. So I have my imaginary base 10, which is like what I showed you on the last page. Now, I'm going to try to make this match my a equals b to the p form. So I have my b to a power is equal to a. So I know that I normally don't tell you to write equals when there's not an equals, but in this case we're going to do it just so I can show you the purpose of this. So now I have 10 to my power is equal to a, my power being log of 4. Now I'm going to switch this into my logarithm form. So I'm going to switch it to log b of a equals p. So I have my log of base b, and my base is 10 in this case. So I have log base 10 of a is equal to my power. Now, this is where I can put my power back in because my log base 10 of 4 is my power. So I have log of base 10, if I'm just copying this straight from here, log base 10 of a, nothing has changed on the left-hand side, is equal to my power. So I have log base 10 of 4. Now, since I have log base 10 of a and log base 10 of 4, I can just say that my simplified answer is 4 because I'm going to pick the letters and the numbers that are in the corresponding piece. But I have to have the same base of my log in order to do this. Now, if you notice, in that same problem, I had my base 10 here, and it was to the log of a base 10. And I was basically able to just get rid of this stuff, and I was left with 4. So we can do that on all of these problems. If we have a base of our exponent to a log with the same base of 8, so this is 8 and 8, these basically go away, and I'm left with x. Now, if you didn't follow that, rewind and watch that part again. Now, this type of problem is a little bit different. Notice that I have log 7 of 7 to the negative 3x. Now, if I go back a page to the first one, I had log 7 of 7 is equal to 1. So, if I have log with my base and my answer being the same thing, then it is equal to 1. So I have log 7 of 7, which is 1, and then I have left over my negative 3x. Now, in your head, you're saying, well, negative 3x is still in my exponent, so how am I supposed to get rid of that? Here's how we do it. We look back, and if we have log base 7 of 7, I can take this negative 3x and pull it out in front. So I can change this to negative 3x times the log base 7 of 7. Now, log base 7 of 7 is 1, so I end up with negative 3x times 1, which is just negative 3x. Now, it's basically the same concept of this. Since I had base 8 for my exponent and base 8 for my log, I can do the same thing here. I have base 7 for my log and 7 as my answer, so I can move this, cancel this piece, and I'm left with my exponent. Now, this is an awesome trick, so let's do the next one. Now, the thing that we notice about the next one is that I have 2 and then 64. So these don't match. But I can change 64 to be 2 to some power. So I can use my factor tree, and I can go to 8 and 8. And my 8s go to 4 and 2, 4 and 2. And then my 4 goes to 2 and 2, and 2 and 2. Now I have 1, 2, 3, 4, 5, 6 2's. So I can change this equation to be log base 2 of 2 to the 6th power times x. So now I have base 2 with my 2 here. So if I have 2 here and 2 here, I can bring this out in front. So I have 6x log base 2 of 2. And my log base 2 of 2 is just equal to 1. So I have 6x times 1, which is 6x. Now, finally, we have e and natural log. So our our natural log is how we undo our exponential function. If we look back here, down here where we wrote this down, we have our log base e of x is equal to natural log of x. So my my natural log is going to undo my x and vice versa. So if I have e to the natural log of 20, these are basically going to go away, and I'm just going to be left with 20. All right, if you need to rewatch this part again, I understand. If not, make a bubble with a question so that I can help you in class. Have a great weekend.